Okay, this is lesson 1 of module 7. This module will focus on irrational numbers. And so the first lesson opens with the Pythagorean Theorem, which we've already been introduced to this year back in module 2 and 3. We've had some lessons on it. And so this opening exercise, which you don't have in your notes, there are 3 triangles here. And I would ask you just to use the Pythagorean Theorem to tell what you can tell. What information could you find out about these 3 triangles? Additional information besides what is labeled on them. So using the Pythagorean Theorem and what you know, go ahead and pause the video and work on those 3 triangles and come back and we'll talk about them together. If you need to look up the Pythagorean Theorem, you can do that in your notes or do a quick Google search for it and you'll find it. Okay. Okay, let's start with the triangle on the left. And so hopefully you found that for this triangle, using the Pythagorean Theorem, you can find this missing side right here. And so what we want to do is use the Pythagorean Theorem to first write an equation. And it says that a squared plus b squared is equal to c squared for a right triangle. Now we're told this is a right triangle, so the Pythagorean Theorem should hold, and the a and the b are the legs of the triangle. So here's one leg and we're missing a leg, and the hypotenuse is always the longest side and it's always opposite the right angle. So we would have 15 squared plus, we'll call it b, let's let this missing side be b, plus b squared is equal to 17 squared. So 15 squared is 225, and 17 squared is 289. Okay, so then now we want to solve for b squared. So we want to subtract 225 from both sides, and we'll get b squared is equal to 64. And we know that 8 times 8 is 64, so b is equal to 8. So our missing side length is 8 centimeters up there on that triangle. Okay, so let's look at the next one. This next one doesn't have a missing side length. So what is there to find out about this triangle? Well, it's not marked as, neither of these two are marked as right triangles, and so we can't assume that they are, but we can use the Pythagorean Theorem to check. So I'm going to take 9 squared plus 12 squared, and I'm going to ask myself, is that equal to 15 squared? And if it is, then I'll know that I can say that that's a right triangle, but I can't until I know that. So this is 81, this is 144, and this is 225. By the way, you're going to find that knowing some of these perfect square numbers is really helpful. So 81 plus 144 is 225. Okay, so the Pythagorean Theorem checks out for this triangle. So what I know about this triangle is that it is a right triangle, so I can add that piece of information to the diagram. Okay, so let's do one more. So this one, we're going to check and see if this one is a right triangle. It doesn't look like it is, but what you need to know about diagrams, in books and in print like this is that you can't really trust your sight to know whether that's a 90-degree angle or not. They're not always drawn to scale or that, that sort of thing. So this 7 squared is 49, 4 squared is 16, and again, this is a question, are these equal? And 8 squared is 64. Okay, so 49 plus 16 is going to be 50, 65. So 65 does not equal 64. So that is not a right triangle. Okay, it's pretty close. Not a right triangle. Okay. Okay, so let's look at example 1, and we're told to write an equation that will allow you to determine the length of the unknown side of the right triangle. Okay, this is what we just worked on. So so first thing you want to do is maybe define a variable for the unknown side. So I'm going to call it b, you could call it x, you could call it whatever you want. But go ahead and write an equation for that. Pause the video. Okay, so as I write this equation, I'm going to keep in mind the Pythagorean Theorem. Okay, and one thing I might not have mentioned again is that if you don't know in a given triangle what the hypotenuse is, just know that it's always going to be the longest side, and it's going to be the side across from the right angle. Okay, so for instance, in this third example here that we did, if I wasn't sure which one was supposed to be the hypotenuse because there's no right angle labeled, if it is going to be a right triangle, the longest side will be the hypotenuse. Okay, so the 8-inch side had to be the hypotenuse in that if there was going to be one, which there wasn't because it didn't end up being a right triangle, but just know that. Okay, so the equation that we're going to write is, so these are the legs here, the 5 and the b are the legs. So this is 5 squared plus b squared is equal to 13 squared. Okay, so go ahead and solve that equation to determine the length of b. Okay, so this gets us to b squared equals 144. 144 is a perfect square. I know 12 times 12 equals that. So I know that b is exactly 12 centimeters. Okay, let's look at the next example. Again, write an equation that will allow you to determine the length of the unknown side. So the side we're looking for now is opposite the right triangle. So I know that's the hypotenuse, so I'm going to call it C. Again, you can use whatever variable name you want to. I'm just using the letters that are commonly used for the Pythagorean theorem. Okay, so now go ahead and write that equation that will allow you to determine the length of the unknown side. Okay, so you should have written 4 squared plus 9 squared is equal to c squared. So we've got 16 plus 81 is equal to c squared. So this is 97 is equal to c squared. Okay, so at this point, this problem is a little different than the first example because 97 is not a perfect square. I can't just think of a number to multiply by itself, a whole number to get 97. So I have to do something a little different. And when we were doing the Pythagorean Theorem problems before, we left our answers in this form. We just said c squared is 97, so that's as that's as close as I can get. But we're going to work now on finding more exact answers for these problems. So what I want to do is think of what would it be close to? What perfect square is 97 close to? And and I can see that 97 is pretty close to 100, right? So, and in fact, 97 is between two perfect squares. It's less than 100, but it's greater than 81. Okay, so the length would be, I could say that this length of C would be somewhere between 9 and 10. Because if C squared was 81, then C would equal 9. And if C squared was 100, then C would equal 10. Okay, so I would know those things. So I know that in this case, it's going to be between 9 and 10, and probably, not probably, but definitely closer to 10, because 97 is closer to 100 than it is to 81. So this side length here, C, is going to be pretty close to 10. So I would write C is approximately 10 centimeters for this triangle. But I can get even closer. So if I know that, and for this I would encourage you to use a calculator. I know that C is closer to 10 than 9, but that it's less than 10. So I could pick a number that's just a little bit less than 10 and square it and see what I get. So what if I picked, what is 9.8 times 9.8? So I can try to get close this way. So get yourself a calculator and do this. And I see that this is 96.04. So what does that tell me? It tells me that 9.8 is too small, right? So let's try 9.9. And doing this, I can kind of zero in on my number. So now I'm going to do 9.9 times 9.9. And I'm getting 98.01. All right, so what do those two pieces of information tell me? Well, I know that 97 is in between those two numbers, right? Between 96 and 98. So my length here has got to be between 9.8 and 9.9. I can take it one step further, between 9.8 and 9.9. Well, I've got 9.85, right? Times 9.85. Okay, and you could verify this, but this is 97, and I'll round it off at hundredths, but it's 97.02. All right, so now we have gotten pretty close within a hundredth to our target here. So now I could give a more refined answer, and I can say C is approximately 9.85 centimeters. Okay, and that's an even better estimate than what we had before of approximately 10. Okay, so it just depends on how close I need to get, how far I would go in this estimating procedure here. All right, let's look at the next example. Write an equation to determine the length of the unknown side of the right triangle. Okay, so let's look at the triangle we have here. And again, the side I'm looking for is the hypotenuse. I know it's going to be longer than 3 and 8. It's the longest side. So I can write that equation, first defining a variable for that side. I'm going to use C. Okay, so hopefully you've paused the video to do this one on your own. If not, do so now. So our equation would be 8 squared plus 3 squared is equal to C squared. And this is 64 plus 9 is C squared. So I've got 73 is equal to C squared. All right, so again, it's not a perfect square. C squared is not a perfect square. So what I need to do is come up with an estimate for C. So why don't you work on that one, pause the video, see how close you can get to an estimate for C. All right, so the two perfect squares that 73 is between would be 64, and which is 8 squared, and the next one would be 81, which is 9 squared. So I could say that, so if C squared was 81, then C would be equal to 9. And if C squared was equal to 64, then C is equal to 8. So which one is it closer to? Is it closer to 8 or closer to 9? Well, how far is 73 from 81? That would be, it's 8 away there, and it's 9 away from, let's see, 6, yeah, it's 9 away from 64. So it's pretty close to in the middle, but closer to 9. So I could leave it at C is approximately 9 centimeters, or I could check for a little more accuracy. What if I checked 8.6? What is 8.6 times 8.6? So I chose a number that's closer to 9, but somewhere in the middle, which is what my numbers are telling me. Let me check that. Okay, so I'm doing this, I get 73.96. So that's getting closer. So I'd want to go a little bit smaller, probably. So I could check 8.5 also. Okay, and I'm going to actually check something that's bigger than 8.5, because this is the last one I want to do. So I'm going to go 8.55, because I know that it's closer to 9, so 8.5 is probably going to be too small. So let's try this one. And when I do that, I get 73.10. Okay, so that's getting really close. So I could say, if I took it this far, and it's okay if you just go to the integer, that's fine, but a closer estimate would be 8.55 centimeters. Either of those would be good. good answers for that. Okay, this next example leaves us with a little bit more to figure out. So let's look at it. Example 4. In the figure below, we have an equilateral triangle with a height of 10 inches. What do we know about an equilateral triangle? Okay, so you have to think back, remember what equilateral means. Give you a second. And then let's just look at the word equa, meaning the same, right? That first part of the word. And then lateral, meaning sides. So equilateral says the sides are all the same length. What that does for us is pretty important in order to be able to know anything more about this triangle, other than that the height is 10 inches, is that we can use the same variable for all three sides. We could say all three sides are going to be equal to the same length, and so we can say let x be the side length for our triangle. Okay, x is the side length. Okay, so we know that all the angles are the same too. We know that they're all 60-degree angles. Okay, and we're shown by the diagram that this height, the height of a triangle like this is always a perpendicular height from one of the bases. So this is a right angle here, which means this is a right angle over here. We have two angles and we have a side here, and then these angles we know the angles are all the same, and we know this side and this side are the same, so we know that these two lengths have to be the same too. So these are congruent triangles here. This triangle here is congruent to this triangle here, and we would know that by reflecting, right? We could reflect right over this midline where we've drawn the height. Okay, so we're talking about the Pythagorean theorem, and we can see that we have these two right triangles here. So what if we decided to use one of the right triangles and write the Pythagorean theorem for that triangle? So I'm just going to draw one of them here. So here's our angle here. We know that this side is 10 inches. We know that this side is x. So we just need an expression for this side length right here. Okay, so you could think about that. What could we call that side length? We know that this entire side right here is x, and we know that these two segments, it's dividing these in half because these are congruent triangles, so these have to be the same. So we could say that this side length is 1/2 times x. Okay, so we've got the hypotenuse is x. The hypotenuse is x. One of the legs is 10, and the other leg is 1/2 x. So let's look at what happens if we use the Pythagorean theorem here. And maybe if you're feeling confident about this, you should pause right now and try it on your own and see what you come up with. We could think of an estimate for what this side length would be, and we would know that it would have to be more than 10 for one thing. It would have to be more than 10 because the hypotenuse is the longest side of a right triangle. So, but go ahead and pause now and work on this. Okay, so let's do this. So we know that 1/2 x is one of the sides. And so we're going to square the whole thing. 1/2 x times 1/2 x, right? And that's plus, so it's like a squared plus b squared. 10 is, we'll call 10b. So this is 10 squared is equal to the hypotenuse squared. Okay, so we've squared each of the side lengths. So to think about 1/2 x times 1/2 x would be 1/2 x squared. So the 1/2 times the 1/2 is 1/4. X times x is x squared. 10 times 10 is 100, and then x squared is already simplified over there. Okay, so now we need to think about how we can continue solving for x. Okay, so what we want to do is we want to subtract this 1/4 x from both sides. Let me show it in color so we can see what we're changing. We're going to subtract 1/4 x squared. So we want to get it off of that side. We still have plus 100 is equal to x squared, and then the part that we're subtracting. So we're subtracting 1/4 x squared from both sides of this equation. So when we go to simplify, that part's going to become 0. Excuse me. Zero plus 100, well, let's just write it, well, that's fine. 0 plus 100 is equal to, now we've got x squared minus 1/4 x squared. So what this is really 1 x squared. So we have 1 minus 1/4 times x squared. We have 1 here minus 1/4 of them. So we're left with this equation. 100 is equal to 3/4 x squared. Okay, so if this step is giving you trouble right here, this step x squared minus 1/4 x squared, just think of x squared as a variable, right? Be just plain old x or just plain old y or whatever. We're treating these as kind of like terms, and so we add or subtract the coefficients, okay? So we had the 1 minus the 1/4, and that's how many of them we have. So think about that some more, and maybe review some of the solving equations types of topics, and that would help you on that. Okay, so what we have is this. We have 100 is equal to 3/4 x squared. So what I want to do now is I want to know what just x squared by itself is. So I'm going to take and multiply both sides of this equation by 4/3. And you'll see why in a minute. Hopefully you see why already. Multiply by 4/3. So times 3/4 x squared. So I multiplied both sides of that equation by 4/3. And then what's happening is this becomes 1, right? So now I have 4/3 times 100, which is going to be 400 thirds, 400 over 3, is equal to x squared. And if I simplify this, this becomes 133.3 repeating. So that's approximately. So we've got x squared is approximately 133.3. Okay, so now we're back to where we were before. And so we're on our way to finding the side length of this equilateral triangle, right? So we're going to be able to know pretty closely what the side length of that is. Okay, so if x squared is 133, what is the closest square to that? So if x squared was equal to 144, then x would equal 12. So it'd be less than 12, right? Because 133 is less than 144. But let's look at, so the next one would be 121. So if x squared was 121, then x would equal 11. So x is between these two whole numbers, right? Between 11 and 12. And we could ask ourselves, which one is it closer to? Is 133 closer to 121 or closer to 144? Well, it's a little bit closer to 144. So we could say x is approximately 12. And once again, we could get closer. Maybe we could try some decimal approximations. Maybe it's around 12.5, but this is close enough. So our side length of this triangle is approximately 12, which does make sense because this height right here is 10. And so it needed to be bigger than 10, but not that much bigger than 10. So that seems reasonable. Okay, so that was a little bit more involved of an example. We had to take a few more steps, use some things we knew about geometry to be able to tell more about that triangle. Okay, so now you have some exercises. You have exercise 1, 2, and 3, and then we'll summarize this. So go ahead and pause the video, and the directions here say to use the Pythagorean theorem to find a whole number estimate, so just the closest whole number for the length of the unknown side of the right triangle. And then explain why your estimate makes sense. And that would be by showing the nearest perfect square numbers. Okay, so work on that and then come back and we'll correct those together and then you'll be ready for the problem set. Okay, so for this first one, I'm going to call that side x, and I'm going to say let x be the missing side length, or missing leg, I'll call it a leg, missing leg length. I can say that x squared plus 6 squared is equal to 11 squared. So x squared is equal to 121 minus 36. So x is approximately 9 centimeters. 9 times 9 would be 81, so it's a little more than 9, but it's closer to 9 than to 10. And we were told to find the closest whole number estimate on this one. Okay, let's look at the next one. Length C, and so let C be the hypotenuse of this triangle. And 36 is equal to the square of C. So 136 is going to be between 144 and 144 is greater. And then the next closest square would be the 121. So we've got 11 squared and 12 squared. So we just need to know if it's closer to 144 or closest to 121. So it's 15 away here, because 121 plus 15 would be 136, and it's only 8, a distance of 8 away from 144. So we'd say it's closer to 12 squared than 11 squared. So we can say C is approximately 12 inches. Okay, the reason being, my explanation that I would write out would be that 136 is closer to 144 than to 121. And therefore, my side length C is closer to 12 than to 11. So again, it's the closest whole number estimate here. Okay, one more. Number 3, once again, we're going to use the Pythagorean Theorem. I'm going to let this be x. So let x be the missing leg length. Okay, x is the missing leg length. So if I use the Pythagorean Theorem, I'm going to have x squared plus 9 squared is equal to 11 squared. So I'll have x squared is equal to 121 minus 81. Whoops, x squared. So x squared is equal to 40, which is not a perfect square. So we've got to find what perfect square it's closest to. And I'm going to say 36 is probably the closest. 40's bigger than 36, and the next closest one would be 7 times 7, which is 49. So it's between 6 times 6 and 7 times 7. So closer to 36, it's only 4 off this way, and it's 9 off right here. So we could say our missing leg length x is approximately 6 millimeters. That's my closest whole number estimate for that. Okay, and then the explanation, which you need to write out, is just what I said, is that it's between two perfect squares. 40 is between 49 and 36, and it's closer to 36 than to 49. So it's the closest whole number would be 6 millimeters. Okay, let's just summarize this lesson. This is in your problem set notes. And it talks about perfect squares. So we know perfect square numbers are those that are the product of an integer factor multiplied by itself. So 25 is a perfect square because it's the product of 5 times 5. So I think you're pretty familiar with that. When the square of the length of an unknown side of a right triangle is not equal to a perfect square, you can estimate the length by determining which two perfect squares the square of the length is between. And so we did several examples like that, and here's another one for you. Okay, good luck on the problem set. In the next lesson, we'll be talking more about square roots and kind of introducing a little bit more terminology for that, and getting a little more in depth about the actual numbers and where they are on the number line. Okay, so good luck with this problem set, and we'll see you back for lesson 2.